Jonathan's going to tell us a little bit about his initial forays into a problem that he's going to work with Curly and himself on as part of his fishing trip.
All right, so the first thing you might notice is that the title seems very, very strange, and the big part doesn't seem to go with the little part at all. Mostly the reason for that is I like tying things into pop culture, and in algebra I don't get to do that very often, so I have a prime opportunity to relate things kind of nicely to pop culture. If you're expecting endgame spoilers, your mind may be put at ease. I have no intentions of endgame spoilers, but there are some baseball players that relate very, very nicely to the Avengers. Um, we have a Steve Rogers who played for Montreal back in the 70s and 80s, Cal Ripken, whose nickname was the Iron Man, and Noah Syndergaard, with his kind of long flowing blonde hair, gets nicknamed Thor, and he's also kind of a big imposing guy, so he gets nicknamed Thor. So I figured it all kind of relates very nicely. But the broad idea of what I want to do is kind of describe a way of kind of ranking batters and pitchers in baseball. Right. So to give kind of a broad overview, just some introduction to baseball, and then an introduction to the problem. Then I want to go and look at kind of how I'm going to go and try to solve this, and then try and apply some of this to what we know about baseball, and then see how that works out. So broadly, we have that the building block of the baseball game is we have an at bat. So we have something where the pitcher is going to throw to the batter tries to hit the ball. The at bat ends when either the batter goes out or reaches base or something to that effect. So we assign like we have a pitcher going to go and throw to a batter. Okay, and then we take these building blocks of at bats and then we go and we build them into innings. So we have the road team will go in at bat, and then once 3 of the road batters are put out, then the home team comes up. The home team bats until 3 of their players are put out, and then we have kind of this cycle between road and home batting, and we'll call one of those an inning. And then after we've had 9 of these cycles or 9 of these innings, the game ends, assuming that one of the teams has scored more than the other one. Okay, and then the broad idea of what I want to do is just generally, well, let's see if we can find a way of kind of ranking the best batters and the best pitchers based on who's currently the best in both pitching and batting. But then also kind of one idea that I thought about was, well, what if I could kind of come up with a way of predicting into the future who will be a good pitcher or a good batter maybe a couple of years into the future. See how that goes. And so we'll just refer to these players as prospects. So they're players who aren't exactly, who you wouldn't consider to be the best now, but maybe in a couple of years they'll be pretty good. So one of the problems that you run into is that there are 7 different tiers or levels in professional baseball. So you have the major leagues, but then you'll have each of these major league teams will have minor league affiliates. So you'll have an affiliate in AAA, a AA team. Then you have 3 levels of A ball, which are called high A, just regular A, and then low A. And then the lowest tier that you can wind up in is rookie ball. So, and kind of the problem with this is that the teams in each tier will only play amongst each other. So you'll only have major league teams play against major league teams, AAA teams will play against AAA teams, and so on. It's actually worse than that because you have the AAA is partitioned into 2 groups. You have one that's kind of broadly on the East Coast. You have another one that's on the West Coast, and they don't play each other either. AA is split up into 3 groups. You have one that's kind of in the Northeast, one that's in the Southeast, and a 3rd group in Texas. High A's, it's the same kind of thing. So you have all of these different partitions, and you have teams that aren't playing against each other at all. But still, I look at this and say, well, I'll try and persist and see if I can come up with some way of ranking everybody. So the one thing that I can kind of take advantage of is that whenever you're going to have any kind of interaction going on at all between anyone with the majors in AAA, it'll be because something like a player in AAA got promoted by his organization to come up to play in the major leagues. So I'm going to try and take advantage of some of those relations to try and come up with something to work out here. So, and then one of the other parts that we can take advantage of that's really, really nice about baseball is that it's really discrete in that it's really easy to see when one play starts, one play ends, and in particular, within any given inning, I'm always in one of 24 states. So I have 3 options for outs. I either have 0 outs, 1 out, or 2 outs, and then I either have a runner on first or not. I have a runner on second or not, and I have a runner on third or not. So 3 times 2 cubed. So I'm always in one of 24 positions. And I can kind of take advantage of that to come up with this ranking a bit. So the main idea is kind of this quantity that's called win expectancy. So the idea is really simple. It's if you give me the current essentially the current state of the game. So you give me the current score for the road and the home team, you give me the inning I'm in, and you give me the base out state that I'm working at in the current inning. I can come up with a way of describing the probability that the home team will win the game. It's just, it's easiest to go and landmark it in one way. It's easiest to just say, do it in terms of the home team winning the game. And then we just base this on the assumption that both teams are of average talent, just kind of a simplicity assumption. So it's a bit of a hassle to go and calculate it, but it's pretty much just go and get run distributions on innings and then make some multinomial distributions and kind of see where you are at the current place. So it's a bit of a hassle to calculate, but it's fairly easy once it's all calculated. So a couple of quick examples of the win expectancy. When we start the game off, the score is tied at 0. There's nobody on base. There's nobody out. And because we're assuming that both teams are playing at average talent, well, it's just a coin flip. The probability that the home team wins is the same as the road team wins, 50% both ways. But then it could be that after the first batter does something, the win expectancy will clearly change a bit. So if the first batter of the game goes out, the first batter is on the road side, so him going out would go and put the probability that the home team would win up a bit, puts it up about 2%. In contrast, if the first batter of the game goes and reaches base, the road team gets has a better probability of winning at this state, so the probability that the home team will win will go down about 3.5%. And then also what we could see is that if the first batter of the game hit a home run, the probability that the road team would win goes up a bit, so the probability in this case for the win expectancy for the home team goes down to about 40%. Okay, so we can go and kind of work out kind of a practical example of how the win expectancy plays out. So being from the Toronto area, I figured, well, I'd go with about the high water point of Toronto baseball in the last 25 years, which was Game 5 of a playoff series from a couple of years ago. So in particular, going into the bottom of the 7th inning, Toronto was trailing Texas 3-2, but what ended up happening was Texas had a lot of trouble fielding in this inning. So Toronto starts off the inning, they're down 3-2, and what we can see is that the win expectancy that they win at this point is about 36%. So the first batter of the inning was Russell Martin. He grounded a ball to shortstop Elvis Andrews. Andrews botched the play. He bobbled the ball. Martin was safe at first. So Martin being safe at first, it changed the win probability, and it brought the probability that Toronto would win at this point up to about just under 44%. So it increased it about 7.5%. The next batter up was Kevin Pillar. Pillar went and grounded a ball to first base. The first baseman went through to second base, where again Elvis Andrews was there and he dropped the ball. So both runners were safe. They put runners on first and second with nobody out. And doing that, it brought the probability that Toronto would win up to about 54%, so it increased the probability about 11%. The third batter of the inning was Ryan Goins. Ryan Goins tried to advance the two runners with a bunt. Elvis Andrews went to go cover third base, and kind of as you can see from the picture, he again dropped the ball, which put runners at all the bases. So the bases were loaded, and still nobody out. So that went and increased the probability that Toronto would win up to, increased it about another 13%, brought them up to about 68% that they'd win at this stage, even though they're still down 3-2. They're down 3-2, the bases are loaded, nobody's out. The next batter up was Ben Revere. Ben Revere grounded a ball to first base. The first baseman threw home and put the runner on third, coming home out. So what was going to happen after this play was that Toronto was going to have one out, but they still had the bases loaded. So at this point, Texas made a pitching change. They brought in Sam Dyson. Sam Dyson comes in to face Josh Donaldson, so it's still bases loaded, one out. Donaldson puts a kind of a blooping ball that just manages to get over the second baseman's glove. Kevin Pillar scores from third base. Ryan Goins ended up going from second to third, but Revere was put out at first. So now Toronto has tied the score at 3 apiece. They've now got 2 outs. Up comes Jose Bautista. He has runners on first and third. And at this point, there's about a 58% chance that they'll win the game. So a little bit better than half. At this point, very notorious incident happened. Jose Bautista, it's a very towering home run and kind of leaves this very lasting impression with a bat flip. And in doing that, the win expectancy at this point, it put Toronto up 6-3, and it changed their win expectancy from about 58% to 93%. So it increased it by about 35%. So highly significant. After a fairly substantial delay due to some people being unruly, The next batter comes up, Edwin Encarnacion, and he hits the ball about 50 feet, but there was nobody in the general area, and he was able to get safely to first. Putting him safely at first, it negligibly increased the win percentage. The batter after him was Chris Colabello. He put a single into right field, so it advanced the runners up to first and second, now with 2 outs. And then the last batter of the inning was Troy Tulowitzki, and he just kind of meekly fouled out to the catcher. Okay, so what this does is it kind of gives an idea of seeing how the win probability is changing based on some various states, and what we could see is, well, we could make kind of this multigraph, where the multigraph is going to give us a relation between all of the pitchers that Texas used in this case, so Cole Hamels, Sam Dyson, Jake Diekman, and all the batters that Toronto used during the game. So just going through all the batters that they used, and then it might be a bit hard to see, but each edge between a batter and a pitcher is going to give all of the number of times that that batter faced that pitcher. So in this case, Ben Revere, there are 4 edges going between him and Cole Hamels because Revere faced Hamels 4 times. So the main idea with this is that we can kind of do this across every single game. So we could go and look at all of the batters that face all of the pitchers, and one thing that we could see in general is that we're always going to wind up with a bipartite graph, because every at bat is going to consist of one pitcher facing one batter. So we always wind up with something bipartite, which on the surface isn't overly helpful. Because what I said is that I want to come up with something that's going to tie all of the batters together and then something that will separately tie the pitchers together. So far, I'm not really able to say anything about the batters as their own class, the pitchers as their own class, because the only relations that I'm going to develop so far are between pitchers and batters. Okay, and then we could focus on this a little bit, just kind of simplify it and make it a little bit less busy. And what we could notice is that, well, these 5 batters all face Sam Dyson. And in particular, what we could say is, well, we could go and look at how each of their at-bats went against Sam Dyson. So what we said was that Donaldson's at-bat, it increased the probability that Toronto would win by about 2.5%. Batista's at-bat increased the win probability by 35%, and so on. And what I want to kind of do is think about what's going on in terms of a win and a loss. So what I could say is, well, I don't know anything at the moment about relating each batter to each other, but what I can say is that they faced common pitchers. And I can kind of come up with relations based on who they faced in common. So what I could say is, well, each of these 5 players inside of this game, they all face the same pitcher, so I can come up with relations between them based on how they did against this common opponent. All right, so in particular, what I can say is, okay, so Batista had the at-bat that had the best change in the win probability. So what I could say is, well, relatively speaking, he's beating all of these other 4 batters based on the fact that his at-bat had the best win probability change. The next one up is okay, so clearly we've already said Batista beats Donaldson, but then if I look at Donaldson in relation to Encarnacion, Colabello, and Tulowitzki, Donaldson's at-bat changed the win probability, increased it about 2.5%, which is better than any of the other 3. So what I could say is that here Donaldson's going to beat these other 3, and then likewise, same kind of idea. Colabello beats Encarnacion, Tulowitzki, and Encarnacion beats Tulowitzki. Right, so what I can say is, well, I've got 4 wins here for Batista. He beats each of these other 4 batters. Donaldson, he gets 1 loss because he loses to Batista, but he beats the other 3, and so on. And then I can kind of represent it with this nice digraph. So what we'll say is that I have this edge going between batter J and batter K if batter J beats batter K, or in this case, has an at-bat that increases the win probability better than an at-bat from the kth batter in this case. Okay, so far what this has said is this has kind of given me a nice way of relating things, but I still want to be able to rank things. So to do that, I need to come up with some ranking method. For kind of where I'm at so far, all I want to do is just come up with something that'll kind of tell me if I'm on the right track or not. And given that I'm looking at matrix systems that are about 3,000 by 3,000, I want to come up with something that I can do reasonably quickly. And there's this really nice ranking system that'll kind of give me what I want. That'll give me a system in which I can come up with rankings reasonably quickly for the size of the data that I'm working with. And the name of it is, it's called the Cully method. This was used to go and rank college football teams before the NCAA changed over to the current way that they're doing things. It was actually made up by an astrophysicist who just had some spare time on his hands and decided, let's try and rank some football teams. So to kind of skip over how Colley came up with his derivation, what I'm gonna do is I'm gonna say, well, I'm trying to solve this system CR equals B. R is gonna be the solution vector. It's gonna hold all of my ratings for all of the players. Inside of the B vector, I'm going to put this quantity 1 plus Wj minus Lj over 2. So what I'm saying is I'm going to take all of the wins that a player has, subtract off all the losses, divide that by 2, and then add 1. So kind of like an average between the wins and the losses, and then I'm just adding the 1. The 1 kind of comes up in his, the reason for it's just in his derivation, which isn't overly important here. And then I'm going to define the matrix C. I'm going to take, on the diagonal, I'm going to take 2 plus the total number of games that a player is involved in. So in this case, kind of matchups between common pitchers. And then the off-diagonal elements will be the negative of the number of times that J and K face each other. Okay, so then the really, really nice thing about this is that the C matrix is positive definite. And kind of, you could see kind of simply just because of Gershgorn disks. So what you would have is that the radius of each of the Gershgorn disks would be 2 less than how far the circle is offset along the positive x-axis. So it gives me kind of this nice decomposition. So because we have a positive definite matrix, I can break my matrix up into a lower triangular matrix times its transpose. So what that means for solving the matrix system is I can just do it now by forward and back substitution. So it simplifies things out immensely. The hardest part effectively just becomes computing the decomposition. That takes a while, but after I've got that, forward and back substitution is easy. Okay, so then to kind of illustrate what's going on with this Colley method for this nice digraph, the example is a little bit trivial just because it's a tournament, but it still gives kind of the idea of what's going on with this. So what I wind up with is for this Colley matrix, I have 6s along the diagonal just because in this case, each of the batters involved in 4 competitions. They face they're in competition with each of the other 4 batters, and they all face each other once. So all of the off-diagonal elements will be -1s. Inside of the B vector, we had that Batista had 4 wins, so his entry inside of the B vector would be just 4 over 2 plus 1, so he gets a 3. Donaldson's entry would be 3 minus 1 plus 1, so just 2, and then the corresponding entries kind of follow immediately. And then simply solving the system, we get this nice ranking vector, which goes and gives me ratings for each of Donaldson, Batista, Encarnacion, Colabello, and Tulowitzki. So the results in this case that kind of follow immediately from what you would expect for the tournament. Batista ranks out as the highest one, Donaldson comes second, Colabello comes third, Encarnacion fourth, Tulowitzki he comes in last. Okay, so then the main idea that I had was, well, now I'm going to go and take that. I'm going to grab every at-bat that happened across as many years as I can get my hands on. Effectively, the problem is that the minor leagues only goes back a couple of years. The major leagues I can get back to the 1800s if I wanted. But so I'm going to go and just, for simplicity, just focus on the 2018 season to kind of simplify things a bit. So what I wind up doing with this is I go and I take all of the at-bats that occur across every level of professional baseball in 2018. So all of the major league at-bats, all of the ones at AAA, AA, all of the single A's, all of the rookie level at-bats. Then go and kind of take this approach. So I'm going to say every time that I see 2 batters, they face a pitcher in common, I can look at how the win expectancy changed in relation to that pitcher they faced in common. Whichever one had the win expectancy whichever one had the better win expectancy gets credited with a win, the other one gets credited with a loss. So do this for all batters across the 2018 season, and then apply this Colley method. So in doing it, I come up, I can only fit about 14 rows on a page, and I couldn't get a second column as well, run out of space. But I get a lot of names that seem very, very familiar and would generally be regarded as top players in baseball. Some of them I didn't recognize immediately. I didn't recognize this name at all. But in looking in particular at this guy, I can see why he finishes really, really highly, particularly for the 2018 season. And the reason is that with runners in scoring position, this batter was hitting about 360, which is very, very good. And in general, kind of the way that I'm seeing how this works is that whenever you have an opportunity to score runs and you bring the runs in, that'll be very, very beneficial because it'll give you kind of a lot of big wins. So the way that I've got this is wins that at bats to change the win expectancy by a fairly large degree. So something like we saw with Batista, where it was changing by 35%. That's a very big win. So effectively, anytime you come into competition with someone, that would be kind of a king move, in that it would kind of beat off anyone else. So that kind of explains why this guy, who's not very well known, finishes at number 4. And again, lots of other names of a lot of guys who are generally considered top hitters in the game. Okay, so then the next thing that I really wanted to do with this was say, well, okay, so this is good. It gives me kind of this idea of saying who's a good hitter currently. But then I kind of want to say, well, what could I do about future players? So in looking at future players, there are lists of top 100 prospects that are released at the beginning of every season. So I just fit as many as I could on the page, so I think I fit about the first 24 something of the top hitters. I could do something similar to the pitchers, but for the most part I've just been focusing on the hitters here so far. So we wind up with kind of this nice list of all of the top players. So they're ranking, as you see, some of the numbers skip, and it's just because in the places in between there's a pitcher there. So the top 5 regarded prospects in baseball entering the 2019 season were all batters. The 6th one was a pitcher, and I guess the 11th one was also a pitcher, and so on. So I take all of the top batters that I can get my hands on and kind of fit on the screen. Okay, and then I was interested to see, well, where do all of these batters fall in this ranking? Because if they all kind of fell in a general area, I would say, well, that's really convenient. So I go and I look at this, and I see these numbers are kind of all over the place. All right, I've got the top regarded prospect in baseball finishes as the 17th best hitter, despite not having played in a major league game at all coming into the 2019 season, which I thought was really, really strange. But then I look at this and say, he had a very, very, very good 2018 season. Okay, so maybe that kind of makes sense, but then I see the second one is down at 460, the third one is at 77, the fourth is at 923, and then I come over here and I see the 33rd ranked best prospect is sitting at 139. So then,
where's the ranking coming from?
Okay, so this is, I don't think it's Baseball America, I think it's just the MLB.com list of top 100 prospects. Mm-hmm. This column is going to be where they fit.
Based on
where they fit in here. Right, so if I had a bit more space, Vladimir Guerrero Jr. would show up 3 more lines down.
Got it.
Yeah. Okay, so I wind up with this, and I see all of these numbers, and there's not really anything kind of orderly at all. So then I just go and look at this, and I start digging around to see, well, okay, why is this showing up kind of like this? And what I'm seeing in general is that these kind of players who have rankings that are the numbers are very small, so like 17, 77, 139. These are all players that are playing in the levels that are close to the major leagues. So they spent most of the 2018 season in AAA or AA. For the most part, AAA, but I think Vladimir Guerrero Jr. spent about half the year in AA. Okay, so that kind of explains some of these ones. And then there are also these very, very high numbers. Like, for example, down here we have Jared Kelenic is at about 2,200, and there are only about, I think, 2,700 batters that I'm looking at. So it seems very, very strange for someone to tell me that the 50th best prospect is actually pretty close to the bottom of all of the batters. And the reason for this is because this guy spent all of 2018 in rookie ball, which from kind of the table at the very beginning, which was the furthest away that you would get from the major leagues. So the way that the ranking is all working is the way that the ranking is kind of working is that it's basing your relations on everyone else kind of around you. Well, the problem for this guy is he might be good in rookie ball and such, which is why he's kind of regarded as a top prospect, but all the people he's going to be competing against aren't that good, relatively speaking. So the problem is that we get these relations that are going from rookie ball up and so on, and he gets all of these kind of weak links that are connecting him to all of the higher levels up, which is why in the end, his ranking for what I'm doing isn't actually that good. And this is kind of what I'm seeing in general. It's all of these players that have very high numbers, just like this one, 1,700, 1,100, a couple more over there in the 1,300 range. these are all players that are in the low minors. So they're mostly just starting out their professional careers, but they're highly regarded. These kind of players like Vlad Guerrero Jr., Eloy Jimenez, I guess Austin Riley, they're players that are more in the high major or in the high minor leagues. So they're players that you would regard as being close to major league ready. And already, these three have already debuted this year. I don't think any of the other ones have come up to the major leagues yet. But the idea is that we have these players where, as their numbers are getting closer and closer to 1, so the rankings are getting better, we'd say they're getting closer and closer to being major league ready. So closer to making their major league debuts. Whereas these players, with the ones that are the big ranking numbers, they have kind of more ground to cover. So they might be coming up to the major leagues in 4 years, say. Okay, so what this does is it gives me kind of something to start off with and something to play around with and see if I can make things better.
So Jonathan, if you look at players that spent the year roughly at the same level,
yeah,
is your ranking corresponding to closely to the ranking, or do you see inversions?
So really, I only got this result about this morning.
Okay.
So I haven't had that much time to actually look into it, just mostly because it took a long time to go and clean out a lot of the data and then also get those C matrices. So the C matrices, to get them, was taking about 6 hours or so to get it. So I haven't had that much of an opportunity to kind of look through and see how, say, look at other players in rookie ball and see where they're finishing. But just looking at this, I think this guy had a very good year, so I would imagine that the other players in rookie ball are going to be below that. That would be my guess, but I can't confirm it at the moment. So then there are also kind of other things I'd like to do going forward. So one is I'd like to include the data from college baseball. So the idea with this that I've got so far is that these are all players that are already in organizations, and it gives kind of an idea of if you're trying to trade for players, it kind of suggests maybe what you want to be trading for. Looking at college baseball players, that'll be all of the players that are coming into organizations within the next couple of years. So it says kind of who you want to be looking at to draft. Ideally, I'd like to also get high school data, but that just looks like it'd be too much of a headache to try and get my hands on. Be nice, but I'm probably not going to be able to do it. Another thing I'd like to do is account for fielding errors. So one of the things that I had was back here, I'd said that Texas couldn't field the ball in this inning, right? So, and in fact, the first 3 batters, it was all based on errors by Elvis Andrus, right? And if he'd made all of the plays, it would have been a very different inning, and these win expectancies all would have changed. So what's happening actually is that in this case, Russ Martin is getting credited for an at-bat that increased the win probability by about 7.5%, but it's purely the result of the shortstop not being able to field the ball. Likewise, Kevin Pillar is getting credit for an at-bat that increased the win probability by about 11%, also because Elvis Andrus couldn't catch the ball. Same thing going on next. Ryan Goins is getting credit for an at-bat that's increasing the win probability 14% because Elvis Andrus couldn't catch the ball. Right? So that's not actually telling me anything about the batter at all, and it's not telling me anything about the pitcher. It's telling me something that's outside the control of both the batter and the pitcher, so I don't really care about it. So what I want to try and be able to do is be able to parse through the play-by-play and be able to say, okay, there's a fielding error here, and try and guess at what the play should have been if the ball had been played optimally, if there hadn't been some kind of a fielding error. And then the last thing that I'd like to do with this is kind of account for what's going on over multiple years. So far, all I've done is I've looked at what's happening in the 2018 season. What I'd like to do is I can only go back to about 2015 because that's as far back as I can get for the minor leagues. So say, well, I've got 4 years of data, kind of decay what's going on over time because what's happening, I guess, in 2018 is more important than what was happening in 2015, but it's still useful to give me kind of some relations of what's going on. So these are kind of ideals to shoot for, I would say. So, thank you.
Questions?
Yeah. David?
I was wondering if you could talk a little bit more about existing techniques for ranking batters. So in particular, is there something that you think isn't done very well by existing techniques that you'd like to improve on or that motivates you to work on?
Well, yeah, so that's kind of something that I would look at going forward. At the moment, I just kind of wanted to say, is this kind of a project that I think has promise? So if I employ a ranking method which, I mean, it was used to rank college football teams at the highest level. I mean, this was used to settle championships. And if I get something that looks very, very strange, it says, okay, this probably isn't something that's going to go very far. So I guess that'd be also something to consider going forward. In general, I'd say it's just kind of an idea of ranking methods in general, kind of getting a good one. So yeah, so it's something that I haven't really looked at. It's something to kind of consider going forward. Yeah, Carol.
I don't really know how to speak baseball.
Yeah, that's okay.
Sorry, but so the Batista kind of exceeded everyone else because there were already three people on the bases, I mean, right?
Yeah.
So it's not clear that that's attributable to him. So I guess you could say it reflects that the pitcher tends to let people on the bases. Is there somehow that seems like a big way in which his extremely much larger increase to the
Yeah.
percentage is not obviously attributable.
Yeah, so there is certainly that aspect of it is effectively everything that's happened before you is a sunk cost. You can only control what you can control, right? It's the idea of you can only defeat the enemies that are in front of you. You can't defeat the enemies that are over there, kind of thing. Well, all we can say is you're coming up, you have this opportunity, you have this guy on first, you have this guy on third, and you hit a home run in a tie game. And it just happens that the way this all works out nicely, you've changed your win probability by 35%. You've increased it substantially. So yes, there's this idea that, well, you didn't actually have anything to do with those guys getting on base. I'd say fair enough.
I mean, the concern is that the win probability is not it's not sufficiently informative of the player's quality. And that would be the concern.
Yeah.
Right place, right time.
Yeah. So there is that.
Player's quality versus,
Yes. So it'd kind of be an issue of sample size, and what I figure is, I'm doing this over a course of a season, right? So in general, you'll get players who will get 500, 600, 700 at bats over the course of a season. So I figure, yeah, exactly. Is you'll get these kind of scenarios. There are also really weird ones that I saw where you had something like a player managed to bunt into a triple play. I don't know how that happens at all, but that's so.
By that you mean you bunted and the bases were loaded and all those guys scored.
No, they all went out.
3 outs.
So you start off with saying like runners on first and second or bases loaded or something. Nobody's out. So you have a very your probability of scoring runs is very high in that situation.
Yeah.
So if you'd scored runs, that'd be very good for your team. So like what we had,
So you mean all of them ended up being out?
they all went out somehow. Like there were massive base running debacles. And there was
Offered this wonderful opportunity.
Yeah, you're-
Yeah. Somebody should have
Watched it up.
exactly.
survived.
Exactly. You're offered this golden opportunity, saying like you've got bases loaded and nobody's out. So like your
Yeah.
optimal situation for run scoring. And somehow everyone went out.
Mhm.
I'm not exactly sure how, but I saw these things showing up and I was very, very confused. But what it would do in that kind of situation is say, well, you would have a very high win probability or a higher win expectancy just because you have this kind of golden opportunity to score runs. You get zero. Not only do you get zero, but you commit 3 outs, which would I would imagine not, which would probably plummet that back down into about the 30s if we had this kind of case and everyone went out.
Well, all right, here's where my baseball isn't very good. If this person hits the ball and somebody catches it, he's out.
Yes,
right?
indeed.
And if they already had 2 outs.
That's the end of
the
the.
third out, then are the other 2 people then?
Well, no,
does
it's
that account for some of this? Like,
yeah. So what happens in that case? Okay, so in this case, okay, so we had runners on first and second. The batter hit the ball and it was caught, so he's out. So all that happens is it just rolls over into the next inning. So all I do is I say, well, I had the win expectancy at this point of 94%, and then what happens is that the probability of the home team winning, given that they're up by 3, starting the top of the 8th inning, is just under 93. So that's what happens in that. So it's just kind of the inning rolls over to the next one, and it's just all about, in this case, base states. So we moved from kind of this base state of 2 outs, runner on first and second in the bottom of the 7th inning, to now being in the top of the 8th inning with nobody out and nobody on base.
So if there were no outs and bases were loaded, and you get an out, you actually
Yeah.
probably affected the outcome of the game more than if there were already 2 outs and you got an out.
I see, yeah.
Right, so it's worse to get an out
Yeah,
early on.
yeah.
Yeah,
But
yeah,
I like the idea of
and this is
not just measuring how much do they impact the outcome of the game, but actually somehow saying, given the opportunity that they have,
Yeah, how they handle the
how did
pressure.
they handle it? And schools, universities do this,
Mhm.
when they're trying to recruit undergraduate students, that what they're looking at is not just their GPA and not just their SAT or SAT score. They're saying, given the opportunities that they had, what did they do with it? Because they realize not everything's equal.
Yeah, and I think to kind of go on that, what you would say is players who are given who find themselves in good opportunities and bring about optimal results, you would say to them more will be given, but to those who can't do it, what they have is taken from them, kind of thing. And just to kind of go with what Jason was saying, well, yes. So what we had here was that at this point we had bases loaded, nobody was out. The win probability is about 68%. And what happened was, to go from this batter to the next one, an out was made, the bases were still loaded, but the win probability dropped down to 56%. So it dropped down by about 12% just by making one out. So, yeah, so situations kind of like this, especially in a one-run game, you know, depending on which way you go, score runs or go out, that'll change quite substantially. Yeah, Terrell had another question.
I mean, so another concern with the sort of percentage approach, and this comes up in the context of ranking, like ranking teachers, for example, in educational outcomes, is, if, I mean, you cannot increase the win percentage by 36% or whatever the teacher did.
Yeah.
The win percentage is okay 94%.
Yeah,
Right?
exactly.
So one thing you might do is you somehow don't just take the raw change in win percentage, but somehow, transform that according to how close you are to either extreme end.
Yeah.
I know there's a concern for when teachers, if we're ranking teachers by how well the students improve, well, if you get a class of students coming in and already at the 94th percentile, and you're a really, really good teacher, but, just by chance they go down to 93rd percentile or something like that.
See, I kind of look at it in the reverse. If I'm looking at this, now maybe the context between looking at it with baseball players and teachers, it varies. But if I'm looking at this and saying, in this kind of situation, I'm dealing with very crucial events. And if I'm getting a player who is doing very well in these crucial events, so these very tight games, late in the game, with optimal opportunities to bring in runners, I want someone that's doing that. I don't really care if a guy is getting hits when his team is already up 10 runs. Because at that point the game is pretty much decided. So in something like this, maybe that differs from I guess teachers versus baseball players.
Well, but again, if you're measuring the quality of the player, this contextual information about what the win percentage was already seems. I mean, that depends on so much that is not reflective of that individual player's quality.
Well, the other side of the coin, though, is that because human beings react differently in different pressure environments.
Yeah.
Is you could say you can have a player conceivably who does well when it doesn't matter.
Yeah.
And there's no pressure, when everybody's winning, they do well. But when everybody's looking at them to turn the tide of the game, then they collapse.
Yeah, and
I guess that might be, if these were automatons, and we're just testing automatons, then yeah, actually, the winning percent, or automaton, yeah, thank you. Then it would be insignificant, the whole, but maybe for humans.
yeah. Well, I think a classic example of this was going from the Yankees in the 70s to the Yankees in the 80s. So the Yankees in the 70s, they had Reggie Jackson, who was known as Mr. October, and then he left the Yankees, I guess in the late 70s, early 80s, and they had Dave Winfield, and the owner, George Steinbrenner, didn't like him very much because Winfield was very good in May, but not so much at the end of the year. And the way Steinbrenner put it was, I want Mr. October, not Mr. May. So that kind of idea. If you want players that are performing well in the clutch, I would
So
say.
the assumption is that there's just enough games during the season that everybody will hit
Yeah.
these high pressure moments.
Yeah, and that's kind of what you figure, is that if you look over the course of a season and a player's playing enough, the sample size becomes 500, 600, things kind of sort themselves out. You get players, they show up in all kinds of situations. They'll show up in situations where you get kind of situations like this. They're trailing, but they have opportunities to score runs and put their team into the lead. They're showing up in kind of situations that don't mean anything. The game's kind of decided one way or the other. Overall, it's kind of, what are you doing that has the most impact on the game, kind of idea.
Well, that's a, so that's the case, you might, well, actually, pose you a question. So in baseball, how much discretion does the coach have about who is at bat when in the game? Like, strategically, how do people-
So there's a lineup that is fixed. So you have 9 people in the lineup and they just cycle through.
Okay.
You do have a bench and can bring people in off the bench, but once you bring a player out, he's out for the remainder of the game.
Okay.
So there is kind of some oversight, but not a lot.
The coach has complete description of who in that group, but you just capturing the coach's judgment.
Yes.
about who they put in.
Indeed. But yeah, so that's actually part of the nice part is that there's not that much that you can do externally. It's just you come up when it's your turn in the batting order and you come up with whatever the context is in front of you. So that's also part of the nice part about this is that, well, there's not kind of that much external factors to this.
So at its essence, the calling method is, really, it's saying, oh, one way you could rank people, let's just think about, not baseball, but maybe football.
Mhm.
One way that you could rank football teams is, well, you get a point for every game you win.
Yep.
Okay, and they say, well, let's take into account, the quality of your wins. So maybe we give you a point for every game you win, and a point for every game, that the opponent that you beat wins, or half a point. Right? And in the calling method, at its essence, it is really an iteration of this, because you're taking, the inverse is really the inverse of an I plus some matrix of spectral radius less than 1, I minus, and then the inverse is I plus n squared plus n cubed. And so it's just giving you this iterated points. So how much, you can weight these in different ways. You've chosen to weight the
Yeah.
inverse in a certain way, to say, the value of winning, immediately is this, but the value of winning a win is weighted this way.
Yeah, and again, as I would go forward, what I'm seeing is that, okay, this kind of works and this is something profitable. I'd probably try and move, I guess I'm going the wrong direction, but I would go and try and pick up something that's maybe a little bit more robust than this, but again, I just kind of wanted something that was easy to implement and had this very nice property that I could decompose and do forward and back substitution.
And then, so Google, you pay rank points
Yep.
much the same way, but they don't do the Scholastic factorization on the 6 billion by 6 billion
Yeah,
matrix. They just, do a power method until they get it refined.
Yeah.
You might consider doing that here too.
Well, I remember one of my buddies from undergrad did a presentation on the calling method, and he did it on, what was it? He was Dutch, so he did it on Dutch soccer or something. And what he found was there was this really weird result where in one of the World Cup qualifiers, so in the World Cup qualifiers, you get 6 teams in a group, and they play each other home and away. So the Dutch got all possible points, so they won all of the games except one. The one that they didn't win, I think they tied Andorra, like some small European country. And I think that was about the only point that Andorra got in the entire group. But the weird part that would happen is the way that the Google ranking worked is because Holland only tied Andorra, they didn't lose anyone, they didn't tie anyone else. Andorra was getting this benefit of getting all of this Dutch ranking going towards them, and it put them at second. It's second out of 6, even though they finished with 1 point. Out of, they're playing 10 games, so they got 1 point out of 10 games. So, they finished dead last in the actual thing. But in the Google one, they finished second, which would actually have been good enough to put them into a playoff for the World Cup. So yeah, so that's one of the problems that you come across with all these ranking methods is that they have some nice properties, and then they're also kind of weird cases where things break horribly.
So what happens if naively, if you tried a different way of ranking
Yeah. So, well, so one of the things you'd wind up with in there is if I just say, well, okay, I'm just going to take I'm going to take batter A and batter B. They both face some pitcher. This guy got more hits than this guy. So there are a couple reasons why I picked win expectancy. One is that this guy might have more opportunities than this guy. With the win expectancy, it doesn't show up as much. The other one is that it's not always obvious. Let me put it like this: it's possible to not get a hit but do something beneficial. So, okay, so coming back here, what happened here was we had the bases loaded, and this runner got put out at second base. So officially, Josh Donaldson wouldn't get credited with a hit in this case, because just the way the baseball is scored. So he wouldn't get credited with a hit, but his team scored a run and tied the game, and he got on base. So that's one of the reasons why I'm using win expectancy here as opposed to something else like batting average. Okay, how about I just pull up the video? That seems like a much better idea.